Hello, this video will be all about the ability system of the Advanced Turn-Based Tile Toolkit. Now the ability system, or the way that abilities are handled, is something, or perhaps the aspect of the toolkit which has changed the most since its inception. Now originally almost everything was handled by the grid manager, including the movement of units and performing attacks and so on. This was later moved over to the player controller for player controlled unit, which then handled both input but also figuring out paths and so on by calling on the grid manager and moving the units, etc., while an AI controller handled the logic of the AI. Then at one point I added abilities through the advanced example map called Jungle Raid, and I was so happy with how it worked that I ended up implementing this as sort of the default for the entire toolkit. And then I've kept expanding upon it to make it more and more flexible. And at this point, abilities are actually a lot more than just what you think of as an ability for a unit in a game, such as an attack or movement or an Overwatch effect or whatever. It now can include all sorts of other things, so like a mode where both players can spawn units, for instance, on either side. That could be handled by an ability, or generally anything that handles either input from the player into the game and the logic or how that input translates into game logic and gameplay, and also the artificial intelligence for AI controlled units. So within each ability is both a lot of nodes related to player interaction and also artificial intelligence. So you can simply then change the entire behavior of how the toolkit acts, how the game basically works and the AI works, just by changing out and modifying abilities. So to start explaining how this works, I will begin looking at where abilities are generally spawned and called. So if we go to core and the turn manager, if you've not seen the video on the turn manager yet, I recommend watching that to understand this better. But in general, when a new actor begins its turn, then it is activated as an interface function called within that specific actor. Now for units, this will activate this activate actor event, which eventually results in running an activate ability call to the player controller. Since if we get the owner of a unit, this will be set up to be a player controller, and then we activate an ability. And if we do not have the specific ability system component added to this unit, then we will activate its default ability. I will get back to this component for more advanced ability interaction in the next video. But by default it will activate the default ability, which is a value which can be set up individually for each specific unit in theory. So you have it here. Here is the default ability. So it's the ability move attack for this unit. So we activate the ability, but this is called in the player controller. So let's look at how this works within the player controller. So in BP player controller ATBTT, we have this activate ability event. As you can see, it takes input for an ability class. If it is called from the unit here, this would be the default ability, which is an ability class reference. So it doesn't reference a specific instance of an ability, it references an ability class. And it inputs itself here, this unit. So then we check, is this being called by the server? And if not, we send a warning, because clients are not supposed to try to activate abilities. If it is the server, then we check if the current active ability for this player controller is valid. So if there is already another ability active before we activate this new ability, we want to deactivate this ability. I'll get back to this one later. And after this, we want to get a reference to a specific ability instance, which is of the class that we input here, or we want to add this to the game if it does not already exist. So this is a function that means we do not have to spawn every single type of ability we want beforehand. They are spawned as they are needed. So within this function, we check first in this this map of ability references, which is contained within each player controller. So this map, it has keys which are ability class references. So for each ability class reference, it's then tied to a specific instance of that ability class. So if we find it, so we have already spawned this ability before and it is referenced in this map, then we just return this specific ability reference. If not, then we spawn an actor of that ability class and we add it to this map, and then we attach it to the grid manager. And we also mark that this ability was now freshly spawned. It was not there beforehand. And then we set the active ability to this ability, which was either freshly spawned or was there all the time. Then we check if this was a newly spawned ability, and if it is, and there are more than one player, and this is not a dedicated server game, then we delay for a couple of ticks. This is just to ensure that if we're playing a network game, that the client will be able to access a newly spawned ability, since it takes a bit of time from a new actor is spawned until all clients have access to it. After this, then on the client that owns this player controller, we want to set the active abilities, because currently this is only done on the server. And we want also the client to know what is the current active ability. So this basically just sets this reference also on the client. After this, we then activate this active ability, which we just set to active. And by default we set it to reassess, and this number 2 should actually be removed. Hopefully you will not see this in a later video, or a later, yeah, if you watch this video at a later point. Then after activating, we do a short delay, and then we initialize all queued actions. We delay for a single tick basically. So initialize queued actions, you should watch the video on the action system to understand what is going on here. But basically, whenever an ability is activated, it is going to queue a lot of different actions. For instance, it's going to show all the tiles that you can move through by spawning meshes or something like that. And that is an action that is entered into the action queue, and it will not be displayed to the player unless or until the action manager initializes those queued actions. So that is about that. But first let's look at what happens then when an ability is activated. Now when an ability is activated, this event is called. Now all abilities, they inherit from this blueprint called BP ability base. Now for those who used earlier versions of this toolkit, the stuff that's handled by ability base was before handled mostly by the player controller, but now it has been switched over here so that you can easily create child blueprints of ability base that overrides all of this default functionality, so that you have more flexibility in how abilities are implemented. So when an ability is activated, as long as you don't override this stuff, then it will set an owning actor. So the actor that is activating this ability will be set as its owner. Now for most abilities that are included by default, this will be a unit, the current active unit. And then we check, do we use a big unit offset? So this is stuff that's related to big multi-tile units. So we'll get into this stuff on a separate video on big units. But what it basically does is that when you hover over a tile or click a tile, if you are controlling a unit that takes up an even number of tiles, which means essentially, well, yeah, this is for a hex grid, but if you have a unit that takes up all these 3 tiles, then it will be centered basically here between all of these hexagonal tiles, which means that when we hover over or click a tile, we want to look at all the surrounding tiles. So we basically offset where we click to account for this, but I'll get into that in a separate video. So that's all that's really done by default in the ability base blueprint. However, most abilities that are actually working like traditional abilities that are used by units and that are like assessed by the AI and stuff like that is actually are actually child blueprints of a separate ability class, which is the BP ability. So BP ability is, as you can see, a child blueprint of ability base, and most abilities in the system are of this type. And here you can see that quite a lot more of stuff is happening when this ability is activated. So first we call to the parent blueprint. So whenever a BP ability blueprint is activated, it first runs through all of the stuff that is in the BP ability base blueprint. After this, it casts the owning actor to a unit, and if the owning actor is not a unit, so this ability is not activated by a unit, then we stop there. We don't activate it any further, because all of these ability types here, which are BP ability, are assumed to be controlled by a unit. If you want something that's different than that, then you should make a new then child actor of BP ability base. I will give an example of such abilities in a later video. After this, we assign this ability to the unit. And what does this mean? This means that we set the owning unit variable for this ability to this unit which activated it. So not just the owning actor, but the owning unit. So this is a reference to more easily access variables that are specific to the unit class, so we don't have to cast every time. And then we get components by the class. This is again if we're implementing the more complex ability system, which I will describe more later. If it is valid, then we want to set the active ability of this ability system also to this. And then we set the owner of this ability to this owning unit as well, which is especially useful for replication. After assigning the ability to this unit, we want to update the attributes of this ability. And what does this mean? Well, this is, we have a boolean here we can check, which is use unit attributes, and if this is set to true, then variables in this ability for like the range of this ability, the minimum range, whether or not we have a diamond shaped visibility. So if we are checking if it's a square grid, do we calculate range with diagonals as the same distance as straight lines, or not as the diamond shaped visibility. So if use unit attributes is true, then it will get from the owning units these default values. If not, then we set these values just to whatever is the default for this class. And then afterwards we set the possible move for move abilities, especially how far can this unit move will be determined by the current action points of this unit. And and the cost of using this ability times the move ability of this unit. Now this, you don't necessarily need to use this for all abilities. You might have different setups for how movement works for your abilities, but this is here if you want to movement to work in this specific way. After this, we check if this ability or this unit is controlled, the owning unit of this ability is AI controlled or not. And what happens next is very different depending on whether it's controlled by a player or the AI. So let's first look at what happens if this ability is controlled by the player. So by default, player activation starts by clearing any possible targets that have been stored in any previous activation of this ability, so that if we activated, say, an attack ability at an earlier turn, and then we activate this ability again at a later turn where things have changed and units have moved around, we don't want to be able to target the same tiles that we did previously. And this is because, as you can see here in the player controller, we only spawn one instance of each ability class for each client. So that means that even if you have 20 different units, then each of those will be using the same ability reference when they are activated. And since this is a turn-based game, we don't need to have separate abilities for each unit, since they only activate it one at a time. So it could have been previously activated by a different unit, so we need to make sure that the possible targets are cleared. Then by default we check if the current unit has more than 0 action points. If not, we want to end its turn because it's out of action points. But if it does have action points, then by default, this is often overridden, by the way, in child blueprints, depending on what you want to do. But this kind of implements like basic general ability. If you want the sort of ability that has a specific range and where you check visibility. But you will see that for a lot of abilities this functionality is overridden. But by default we find visible units in range, and a specific range that is specified here, which, as you saw earlier, could be either specified specifically for this ability, or it could have gotten that from the unit. And surrounding the owning unit we find all the visible units that it can see. And after this it then keeps the indexes of all the relevant units. So by default an ability cannot be used on allies and it cannot target self. So we only keep the units in range which are not of the allied not of the factions which are contained in the allied faction set within the owning unit. And these will be our possible targets. So to demonstrate how this works for ability move attack, if we move this guy over here and we increase his initiative so that we know that he's gonna act first. I need to compile some blueprints, it seems. So there we are. Oh yeah, he has a range of 1, so none of them show up. But if we change the range to something higher, then you can see that all of these units are marked. If we move an ally over here, we see that he is not marked. So these were the units that were returned by this find visible units in range and then keep indexes with relevant units for this particular ability. And this is some specific implementation for optimizing for big units, so I'll get into that in a separate video. After this is done, here are also some defaults that if we want to display the invalid tiles or not. So this is something that is implemented also for the move attack ability, and this is set to true if you have one action point left. So if you're moving, we're showing all all tiles in range and not just the specific units. But this is something that can easily be overridden, of course, if you want something different for your game. And if so, we want to find all tiles in range, and not just the units. But in any case, for the possible targets, or in this case for all tiles in range, in this case for the possible targets, if we do not want to display all tiles, we run the activate action. So the activate action is also something that is generally overridden within separate abilities. By default, if we look at the animate action, since this is an action which is added to the action queue, see my video on the action queue or the action system if you have not done so already. So this is called as the activate action. In this we check first if so if you see here from the input, we input the owning unit here, and we input all the locations that we want to display when this ability is activated. So as this action is activated, we get the unit that we input. This is should be the unit that owns this ability. We check if and this is cast on all clients. This is multicast, remember, since it is an action. So we only want to display these tiles in range if the client which runs these nodes actually owns this unit, so that not all clients in a multiplayer game see the tiles in range, but only the player that actually owns that specific unit. And then we spawn the tile markers from this input array of tile locations. To show how this looks in game, I can go here and I can set the default owning player, this one, to 1, so that it will be controlled by a separate client, and I launch this with number of players set to 2. Let's see. So you can see here that these tiles in range are only displayed for this client, not for this client. And if I move, oops, you can see that it's the opposite here. Since this client owns this unit, the tiles in range are not displayed for the server. So that does it for activating abilities. Now let's look at how abilities work with input from the player controller. So if we go to the player controller, we can see a few things here. We have inputs. So this is input both from the mouse and touch and so on, and we have also when hovering over a tile. So let's start with this one. So that's done using the tick of the player controller. So yeah, there's a to-do here that be warned that if you're making a game with touch controls, you need to disable or just disconnect this tick for them to work properly. I'm gonna try to find a workaround for that later. Then every tick we check if there's an active ability. If there is, then we keep going. If not, then we stop here. Come to think of it, this is not entirely optimal since I'm calling something every tick. This is just, one blueprint for every player though, so it doesn't matter that much. But yeah, don't be surprised if this has changed slightly when you look at this video at a later point. In any case, we then go to a gate, which we can use to activate the hover tick, which is called from the grid camera, if you recall from the game mode and begin play video. And after this we check, is the mouse X location different than what it was, or the previous mouse X location different from what it is now. And if it is, then we want to update it. We want to update it in any case, but we just want to do an hover attempt if the mouse has actually moved. And I could check also the Y location, but I call this every tick, and the odds of where it's almost impossible for the player to move the mouse in such a straight line that the X location does not change while the Y location does. So I only check the X location. If so, then we do a hover attempt in the active ability. And then we have to go back to the ability base to see what happens there. Now first we check if this ability is supposed to have hover events at all. So if enable hover is set to true, then we keep going. If not, we stop here. After this, we check the UI for hover. So this basically checks, is the mouse currently over any UI elements? If so, then we don't want to fire any hover events. After this, yeah, so then we check this. If it's not over any UI elements, then we check if there are any ongoing actions. Have we ordered a unit to move and it is currently in the process of moving, for instance? If so, then we don't want to run any hover events until that is ended. By default, at least, you can always override this stuff, of course, in your own ability. And this looks quite ugly. This should also be fixed up. But what we check now is that, do we use a custom location for when we are hovering? Or do we want to trace for a new location at this point? So this is something that's mostly here to work with touch controls, which cannot get the location under the mouse pointer because there's no mouse pointer, so we input that location beforehand. But if not, then we want to trace for a new location. So we get the player controller and we find the hit result, and if we hit something valid using the path trace channel, which generally means that we are hovering our mouse over a tile which can be moved to, or at least the grid manager. If so, then we set the current hovered location to this location that we are hovering over with our mouse. After this, we check if the tile has changed. So the tile that you're currently hovering over is different than the one that we were hovering over before. So if you keep hovering over the same tile, even if you move the mouse, no new actions are going to run. So this is an optimization measure. But the moment that you switch to another tile, then all the next events are going to run. And what are those? So if we know that this tile has changed from before, then we decide server side, because this is all done client side, then we decide what we want to show on hover. So let's see what happens there. And we input this hover location and also this offset for big units, which I will explain more in a separate video. Now here we set the hovered location again. It might seem redundant, but in this case, previously we set it on the client, now we set it on the server. So for single player games this makes no difference, but for network multiplayer it does, and the same for a big unit offset. After this we get the grid manager and we convert this location that we're hovering over it with the mouse to a grid index. So if we hover over this particular tile, yeah, I can activate here so you can see it a bit clearer. If I pre-generate these gameplay grids so that all the arrays have already been generated for grid locations, then I can display tile indexes, and you can see here the various indexes of each tile. So for an ability, if I hovered over, the moment I hover over to this tile, then when using this convert location to index 3D function, it will return the value 335, which represents this tile. Or provided this conversion is successful. If we are hovering outside the map or some place that does not correspond to a tile, it will not be a success. If so, if it is a success, then we set the hovered tile to this value. Then we check, okay, this particular tile index, is this one of the locations in our grid locations map? This is something I will cover in a different video on the grid and the grid arrays. So, but is this an actual location of a tile that is stored in the grid manager, essentially? So if it does, we keep going. If any of these are false, then we set the hover tile to -1 because it's not a valid tile, and we do a server hover for a non-valid tile. But if it is valid, then we first reset invalid for the client. This is an optimization measure in place to make sure that the client does not set the word location of the hover marker every tick, but only when something has actually changed. Let's see, where was I? And then we run the server hover event, which is an event which is called on the server. So is this actually, so this might be unnecessary, but yeah, it's called on the server. So in both these cases we call the server hover event, though in this case we say that the tile is valid, and we have a grid location and a hover location. If it's not valid, then we just have the hovered location and not a valid grid index. So by default on the ability base, what happens on server hover is that if we have no valid tile, then we say to the client we are not hovering over a valid tile, which by default means that it's going to hide the hover marker. But if it is valid, then we want the client to display the hover marker over that particular tile. So we convert this hovered tile location. We get the precise actual in-game location of a tile, and we input this to the client, also with the big unit offset if necessary, and then we display this hover marker. So this looks, let's see, like this marker here. This is the hover marker. Okay, let's turn this off. Now at this point in the ability, so this, let's see, server hover is generally, and client hover are the things that are generally going to be overridden in the child blueprints, so the BP ability blueprints. And we can look here at the default. So for server hover, the default for BP ability, we first do all the stuff that we did on the parent blueprint in the BP ability base. Then we have this extra check for suggest hover. So this is an implementation of using the AI system within the abilities to give suggestions to the player for what targets it should choose. This is beyond the scope of this particular video though. But if it is not, but in any case, when we hover, we set the hovered tile to the grid index we are hovering over, unless we want to suggest a tile, in which case we're setting the hovered tile over this suggested tile. But then if the hovered tile is greater or equal to 0, then, because if you recall, if we had an invalid tile, we input that as -1. So if we have a valid tile, then we get the hover text of this particular ability, which is a function which is implemented in BP ability, which you can override to get to create appropriate text for when you hover over a particular tile, generally for using with the more advanced ability system. So this is still pretty low level stuff that's happening within most abilities. But then within the specific abilities themselves, this will often also be overridden. So if we look at the BP ability move, it's a bit simpler than the move attack ability. So let's set this as the default ability and explore this ability a bit. So as you can see here, it is quite similar to move attack. The difference is that the move range is based on the action points. and not the move range of the unit in this particular case. So if we look at BP ability move, we can check here at the hover event, and here we again call the parent server hover event, which is what we just looked at, which again calls the BP ability base hover event and so on. But we have some more stuff, because for the ability move we want to actually display a movement path, as we are seeing here. But first we should maybe look then at the player activate event, because this also overrides the default implementation in BP ability of player activate that we looked on here, because for showing tiles in move range, we don't want to use the range and find visible units and display all of this stuff. We want to show instead tiles in move range. So for ability move, this event here is entirely overridden, so none of this code in BP ability is run, but instead we run this stuff. And what happens here is that first, well, we scale the markers. We scale the hover marker and the target marker to the size of the current unit, and this is again some stuff for using big multi-tile units, so I won't go into that here. And then we check, do we have, how many action points do we have? Actually, this should just be removed, so everything is by default. But yeah, if we have at least one action point, then we want to run pathfinding. We want to show the move range as possible move. We store the paths map, which is a map which holds all the grid indexes we can move to, and also the costs of moving there. And then we clear any previous stored locations we had from activating this ability before. If you recall, this ability could potentially have been called at or activated at any previous turn and by any other unit. And we then get the stored paths map we had here, and for each of the keys, which represents the grid indexes of all the tiles we can move to, we want to loop through these. We add some more if we have a big unit. I'll get into that in a separate video. And for each of those, we convert the index, or we find the corresponding actual world grid location corresponding to this grid index, and add this to an array. And this array we then send to this activate queued action, which, if you remember, was if we go to the animate action event here, we can see that it's actually never called in this blueprint. So that means that it just goes to default. So if we run the animate action here and the action name is activate, we do not find it implemented specifically for this ability. So we go to default, so we do the parent animate action, let's see, which is here, and we do this spawn tile markers, which I discussed earlier. So why is it that for the move ability these are displayed as blue tiles then, while for the move attack ability we had red tiles when the ability was activated? And that was done by overriding the defaults here. So the tile markers in BP ability move are set to be this blue transparent material instead of the default red material which is used for the tile markers for BP ability. So that's one way you can then also override how the target marker looks and how the hover marker looks for specific abilities, as well as tile markers that are displayed. So it's an easy way to customize your abilities. So to sum up the activation of the move ability, we basically find all tiles that we can move to in range, and we store these, and then we convert these location or these grid indexes into locations and display them. Then now if we go back to the hover event, we can use this information to display a path to the tiles that we can move to. So first we always clear the previous path, and then we check if we're hovering over a valid tile. If we do, then we update the hovered tile value, and then we check, is the tile that we're hovering over impassable? If so, we do not want to display a path. Is it occupied by a unit? Then we don't want to display a path either. Unless, and this is a corner case for if you're using big units again, if it's occupied by itself, which a big unit can be, then you are allowed to move onto another tile that is occupied by the same unit, but I'll get into that in the big unit video. And then does the stored paths map that we calculated earlier, does it contain the hovered tile? So if all of this returns true, then we want to display a movement spline to this particular tile. So then we use this function within the grid manager where we find a spline path to the grid index, which takes as input the stored path and the hovered tile, and returns then locations of all of the tiles along the path to our target. And then we want to display this path on the client. So we call this event on the client, where we then get the path spline, which is a component within ability move. We update this spline with the points that we calculated earlier. We update the spline point types. This is if we want a different spline type display, if we want to have it linear or curved, depending on how we want the spline to look. And lastly, we display this spline with spline meshes, which is also called from the grid manager. And we store all of these spline meshes that we spawn within an array in this ability, so that we can clear all of these meshes later if needed, that we have easy access to all of the spawned meshes, which is what is done in the client clear path, where we loop through all of the meshes that we spawned and destroy them one by one before clearing this array. So this happens every time we hover over a new tile in this ability. Now we have a separate implementation for what happens when we actually click a tile. But before we look at the specific implementation for ability move, we should go back to ability base, or actually all the way back to the player controller, where this is first called, because here you can see, well, all input is basically handled by the player controller and then passed on to abilities. So if we look at mouse input, then we can see that if we're clicking, get an input action click, or right mouse button in this case, where we can have a separate click. This should actually be implemented as a click event and not directly right mouse button, so don't be surprised if this changes later either. So we if we press a key, then we set this value to primary and to secondary. If we click the second key, this is to easily allow for two different kinds of interactions. And to give an example of how you can have different sorts of input to the same ability, feel free to implement more similar sorts of, to expand on this enum and have different, even more different kinds of input. Doesn't have to be a click, could be the press of a button or anything. And we also store whether or not we clicked or we released the mouse button, and we check if the active ability is valid. If not, we don't want to do anything. If it is, then we want to call a click attempt within that active ability, and we pass on whether the mouse was released or not, what type of click it was, and we keep a reference to the player controller that called this particular ability. We also check if this was a touch input or not, which is used here in the touch implementation. You can look at that. I think it's fairly self-explanatory. And if we use a custom location, which is also something that is, well, it is used especially when interacting with the HTC Vive or other touch controllers or motion controllers. So let's look at what happens during a click attempt. This is also a bit messy and needs to be cleaned up. We use a custom. If we use a custom location, then we just set the click location to that custom location and skip all of this stuff. If we do not use a custom location, then we want to trace for a new location. So if we're not using a custom location and we're not using touch controllers, then we, again, like with hover, we check if we are hovering over the UI. If so, we don't want to click through the UI to activate or interact with the tile under the UI. And we check also if the player pawn, the camera, is currently moving. If so, by default, we do not want to enable click input. And if it's not moving, then we want to check the hovered location, which again we do by running a trace with the path trace channel from under the mouse by the default. It's a bit different setup for touch controls, but the principle is the same. Then we check if there are any ongoing actions. If there are, we don't want to have the input affect the game until all of those actions have played out. And if all of this goes through, then we convert the location to an index on the server. Now this is because the client does not have access to all of the grid locations and things like that. We want to make sure that these sorts of checks are done on the server, and also that we don't have to store that much information for every client. So on the server, we then get this click location converted to an index, just like we did with the hovered location earlier. And we also update, we check if it's a success, and then we decide what, this is also an implementation for touch controls. For touch controls, we do not have really hover events, or it doesn't work with, since we do not have a mouse that we're hovering essentially. So instead it works with the first click or the first touch you do with a finger. You're going to show the hover. So for the move ability, this would be the spline to where you're moving, and then for the second click you're actually going to interact. So it's a two tap action. But if you're not using touch controls, so for mouse and keyboard, if we click, we want to interact immediately the first time we click. And then we call the server interact event, which by default does not have any implementation in the ability base and must be overridden in all abilities that want to have some sort of input. So let's look at how this is implemented in BP ability. So if we look at BP ability and we look at input, we have here the event server interact. And here we check, did we click a valid tile? If not, we don't want to do anything by default. And by default, we also just want to do something when the mouse is released and not when it is first clicked. Now this is of course stuff you can override in your own abilities if you're doing different kinds of implementations, such as like dragging the mouse to select something in the game or whatever. And by default, we also just want to do something if we do a primary click, not a secondary click. So after this, we check if we have clicked a valid target. And what is valid can, of course, depend a lot upon the ability. So this is a function that you in general just want to override in child blueprints. So by default, it checks if this index is within the possible targets, if this is how you decide to store possible targets, which is done by default in BP ability, and that is one way to check if the target is valid. If it is valid, we want to pay the action point cost for the unit that is activating this ability. And you can see here that we have a few different ways to do this. That if we're using a custom cost that we're inputting, then we're subtracting this custom cost from the current action points of the owning unit. If we're not using a custom cost, then we're using the AP cost, the action point cost value, which is defined within the particular ability we are activating. And we are reducing the current action points. and setting the action points of the owning unit to this value. Now, if we are using the ability system, we also want to then remove any charges. If this is an ability that has a limited number of charges, we want to subtract this from the ability as it is used. Or if it has a cooldown, then we want to set this ability on cooldown after it is used. So that is what is done with these nodes here. So after paying the action point cost, we want to clear. So this is an action that by default clears the tiles in move range or the tiles in attack range and stuff like that, and you can see it implemented here in animate action with clear. So by default this is clearing the actions by clearing instances of tile markers and removing marker decals and stuff like that. So when we activate our ability with input, we want to clear the activation markers before executing the ability, which is the next thing we do. So executability is again a sort of function that you will in general want to override on child blueprints, and here you have some of the meat of the ability, what actually happens when you click a valid target and the ability executes. I'll get into that in a moment, but after this is done, you then deactivate this ability by default and then reactivate the active object. So the unit is then reactivated. Look at the turn manager and initiative order video for a description of this. So the unit is reactivated, which in general means that another ability or the default ability of this unit will be then activated again, unless it is out of action points, at which point its turn will end. So for executing ability, like I said, there's really not an implementation for this in BP ability. It just returns true. This should maybe return false, by the way, since there's no implementation. But we have to look at specific abilities to see how this is implemented. So let's do just that and look at the move ability. So for the move ability, you can see that it overrides all the default interact functionality in BP ability, since it doesn't need to do all the same checks. It checks again if it's primary, if it's a valid tile, and if the mouse is released, and it sets the click index, and then it checks if it is a valid target, and it has its own implementation here. And if you don't know how to do this already, if you want to override a function that is originally defined in a parent blueprint, you go to functions and you override and you find that specific function, and then you will get this sort of overridden function. So in this case we have a clicked index, and we look at this clicked index and we see if we have this in our stored paths map that we created earlier when we activated the move ability. We check if our possible move value is higher or equal to the cost of moving to this tile. We also check that the cost is greater than 0 to make sure nothing funny is going on. And lastly, we check that there is no unit on the tile that we are clicking, again with the extra check if it is occupied by itself for big units. So if this returns true, that means that we are clicking a tile that we can actually move to. So then we continue, we pay the move action point cost, which is a sort of different than the default action point cost, where you have a few different ways to define this by this enum in the ability. So you could have a static move cost, or you could have a move costs of action points based on the move cost of moving to a particular tile, which is something you would do in a game, say like the early Fallout games where you pay 3 action points for moving 3 tiles and so on. Then you would use from pathfinding cost. Now with a per move attribute value, this is if you have a move if the unit has a move attribute of 10, say, and you are clicking on a tile with a move cost or with a cost of 12, then you are going to pay 2 action points to go there. If you're clicking at any tile that has a cost of 10 or lower, it's going to cost 1 action point. So this is something you can use to have something similar to movement in XCOM, say, where you have a sprint range where you're using 2 action points and a move range where you're using 1 action point. Or you can just have it to be the same as the regular AP cost in the ability. And then this action point cost is then subtracted from the current action points of the owning unit. After paying the action point cost, we want to then clear tiles in range, as I explained when we were looking at BP ability, and then we want to actually queue an action of selecting this unit. So to show you how this looks is that even if we have panned the camera and if we move them, we pan back to this unit that is handled by that action there, and then we execute the ability. And this is also one of these functions that has been overridden. So here you have the meat of this ability, where first you show the target marker on the client. We get the target index, we get the grid locations, and we find the appropriate location. And after this, we set the location of the target marker to this location and make it visible. So this is the marker that appears under the tile when you click. Let's see. After this, we call the move to index function on the owning unit, which causes it to move, and also automatically queues an action of showing this movement. And finally, when it has moved to its destination, we want to hide the target marker. And after this, we return success by default in this instance. After executing the ability, we want to then check if the owning unit is still valid. Now this is something that is added in if the unit should happen to die basically while it is moving to that index, which can happen if you have implemented something like traps or an overwatch effect, which is something I've done in the advanced example. So if the unit has died on its way when moving, we don't want to reactivate it. So we just stop there, but if it is valid, then we deactivate this ability, and then we reactivate the active object, just like we did earlier in BP ability. Now, all abilities have different implementations of this stuff and will vary quite wildly in how they work. And you can look at various abilities, both the default core abilities, but also abilities in the advanced example here for some examples of different kinds of abilities which work very differently from some of these base ones. So it just depends really on how much of the default functionality you want to override in BP ability, and also if you want in BP ability base, which gives you a lot of freedom in what sorts of gameplay you want to have. But in another video I'm going to show how to create your own abilities from scratch. However, for this video I have one more thing to look through, and that is the ability system, which is found in core and units, and it's a component that is attached to units, so therefore it is in core and units, where you have the BP ability system. And I will look a bit on this and go through it. So the ability system is mostly a way to allow for units to have multiple different abilities, but also for those abilities to have things like cooldowns and charges. And it also is a sort of central hub for the AI to compare different abilities to one another and find out which ability is the most optimal to use for a particular turn. But I will go into the AI part of the ability system in the next video. But let's look at some of the more basic stuff in the ability system. First, the ability system has a event begin play event that fires. It only runs if you're on the server, and then we get the owner of this ability system. It should always be attached to a unit, so it casts to a unit and sets the owning unit reference to this unit. After this, it checks to make sure that it is valid. It waits if it is not valid, and then when it returns true, we get the player controller, which is the player controller which controls the unit which owns this ability system. And in this player controller, we want to add all the abilities that are defined in the abilities in this abilities array. So this abilities array is something that you can modify for any unit that implements this particular component. So let's add this component to this unit here. So now this unit, let's just delete the other ones. This unit, as you can see, has a BP ability system component, and here we have the defaults that can be overridden. By default we have the ability move attack, but let's change this so that we have the ability move and then the ability attack instead. And if we start now, we see that since we are implementing, or this unit has the ability system components, we get this ability bar also. So then we can switch between these different kinds of abilities. And if we look back into the ability system, we see that at the start, the ability system loops through all of these abilities we have selected and then adds these abilities to the game. So since we know that we are likely going to use all of these abilities, we just spawn all of these at the very start of the game and add these as references in an ability reference array. So references to the specific abilities, well, this is just an array of ability classes. After this, we have a cooldowns array, which has the cooldown value of each of these abilities, and also we have a charges array, which holds how many charges we have of each of these abilities. Now by default there's not going to be any cooldown or any charges for abilities, but you can go to the abilities. If we go to BP ability move here, say, and if we show the inherited variables, we can get the, let's see, the default charges and default cooldowns, and you can change these so that the ability will be set on cooldown or become unusable after you've used a certain amount of charges of this ability by changing those values. And lastly, we can define actually in this component if we want to have any starting status effects. So we want this unit to be start on Overwatch, or we want this unit to be poisoned at the start of the game or something. We can also add this in here. Status effects is also something I will be going through later. So that's for the setup of the ability system. And then we have this activate ability if active unit and activate unit ability. So activate unit ability is what is called from BP unit when the unit is activated. After reactivate actor, if we do this unit has the ability system component, then instead of just activating the default ability, we then update the ability box, which is what you saw happening a bit earlier, and then we get this component and activate unit ability. So we get here, and then we get the owning unit. We check if it is AI controlled. If it is, then we evaluate abilities. I'll get back to that in the next video. If not, so if it's controlled by the player, we loop through all the abilities. We check if they can be used, So we check if it has enough charges, and if it is not on cooldown for the first ability we find which is usable, we activate this ability. And then we break this loop so we don't activate multiple abilities. As for this activate ability, if active unit event, this is something that is called mostly from the UI, from selecting an ability in the UI. So this is a check to make sure that the unit that owns this ability system is actually the active unit, and we are allowed to then activate that ability. And we can find the references for this. You can see that within the widget blueprint ability, this is something that is called when we click on an ability widget, which are these icons here. When these are clicked, then this is called, and we call this activate ability if active unit event. The rest of the stuff here is for AI and will be covered in the next video. So that's it for this video. So if you want, you can always go to the advanced jungle raid example map and play around with the abilities there. Now be warned that this example game is a bit more complicated than the base toolkit, and I would build upon this and get stuff from this example mostly when you feel comfortable working with the rest of the toolkit. But if you want to look at some implementations of abilities and so on, this is a good place to look. So to see here, we have various abilities we can choose, such as the grenade ability. There, I shot my own guys. And here we have a status effect, which is the woke status effect. If these units are alerted, that you can see. This is the Overwatch ability, which adds the Overwatch status effect, so that if an enemy unit moves within range, he will shoot it. Then we have the heal ability here, which is a fairly simple ability if you want to look at abilities and see various ways to implement them. And if we end the turn for this guy, then we have the mind control ability too, which we can use to add a mind control status effect, which puts this guy temporarily on our side. But that's it for now when it comes to the ability system. So like I said, for the next video I'm going to go through how the AI interacts with this ability system.